Okay, my name is Pablo Araujo from the Universidad Central del Ecuador, the Faculty of Chemical Engineering School. And today I will share with you a fantastic scientific journal to the South Pole, to Antarctica, especially to the HorseShoe Island. But this work is not a single work, it's a work with great colleagues from different parts of my university, the Faculty of Science. These guys loves numbers and create models, statistics, and blah, blah. La Dirección General de Intereses Marítimos, DGIM, this is from the Navy of Ecuador. Thanks to the Navy of Ecuador, the scientists, we can go to Antarctica and create science in the pole. The Chemical Oceanographic Unit from the University of Leiden in Belgium. So, my presentation is have very simple 4 points. The first one, why Antarctica matters, why the South Pole matters, and why we decide from the middle of the world in Quito, Ecuador, travel to the South Pole to take samples for the gases. And a very quick understanding why methane and nitrous oxide are important. In the last part, I will present the results of our Antarctic expeditions in 2023. Okay, so Antarctica, it's very important that we have in mind that Antarctica is the world's refrigerator, and the global change of climate change will cause stress on this refrigerator. So if in Antarctica lose ice, the consequences around the world will feel. What happens if in our home the fridge goes down? Okay, and the adventure is in the scientific research camp of Turkey. This research camp is based on HorseShoe Island Iceland. And in this part is very interesting. You can see this is the island, and all of these bays are surrounded by glaciers. Okay, for the people, this is the last part of South America. In this point in Punta Arenas, Chile, all of the researchers, we take the plane to travel here, King George Island. This is the best way to go to Antarctica because it's 2 hours flying if the weather conditions are good. But if the weather condition is not good, the plane doesn't come the journey. The other way to go to Antarctica is navigate sailing for 3 or 4 days in this part of the sea. This is called the Drake Pass. Also, if the weather conditions are good. So when you get here in King George Island, whatever with plane or ship, you have to travel 4 or 5 days to this point. This is HorseShoe Island, just down the Antarctic Polar Circle. Look, this is HorseShoe Island. It's a very nice place. We have a very lucky. In this part, in these rocks, you will find the scientific research park of our friends of Turkey. Look at the glaciers. I am amazing. This is on summertime. They are amazing. They're beautiful. When the ice breaks, the sound is like a thunder, and it falls into the water, the ice. But when the ice break, and when the glaciers break and convert to an iceberg, there's something happens with these gases, methane and nitrous oxide in the bay. So, as everybody knows, methane and nitrous oxides, they are greenhouse gases. Methane is 20 more stronger than carbon dioxide, and nitrous oxide is almost 300 times of the carbon dioxide. If we put this in a timeline of 100 years, 1 molecule of methane lives 25 more times than 1 molecule of carbon dioxide. Okay, so these gases are bad. This gas causes a global warming potential. So we prepare our equipment. The base equipment is a Niski bottle that you can see. And we deploy the Niskin body from the small sea, if the weather conditions are good, in the for 10 meters deep. This layer of 10 meters in the sea is very important because in this part there is a lot of interchange of the gases between atmosphere and the sea, and also a lot of processes related with phytoplankton and the light penetration in the sea occurs. After that, we collect the samples. We divided the bay of the Horseshoe Island in 30 different sectors, close to the border, close to the glacier smelts, and in the middle, we capsulate the water. We stop all of the microbial growth inside the bottles using mercury chloride in a saturated conditions, and we close the bottles. So the results in this study are very interesting because we found this is the heat map of the methane emissions in Horseshoe Island. Look the scale, please. The lowest value is 500% saturated methane from the sea, and the highest value is close to 2,000 times. To understand this, the normal air on the sea is 100 saturated, but in the bay, always is saturated. We think that is when the ice melt carry bacteria, or maybe in the island. 3 minutes, yes, I almost finished. Increase this methane for to the atmosphere is not a good news for us. Nitrous oxide level is quite different in the island. In some part, you can see here the we 120 saturated level. Well, it's okay, it's normal. And in the other part of the bay, we can find a lower emissions from nitrous oxide. So in this part of the sea, open sea, we can say the ocean attracts nitrous oxide. It's good, but in the other part, the ocean emit nitrous oxide. This is related with the denitrification process on the water sea. If you are interested about the denitrification process in Antarctica, come to the session 11 at 4 p.m. of today, and I will continue this this presentation. So we have the idea. Our first idea is the methane comes from the when the glaciers melt. We have to comprove this hypothesis. We have to do more travels to Antarctica to take more samples. See? But you don't forget, Antarctica is our world refrigerator. Yeah, Antarctica is full of secrets. A lot is crucial for us, for the humanity. If Antarctica lose the ice, we know in the Galapagos Island what happened because around of Antarctica is created a lot of the nutrients of the sea. That's it. Thank you very much for all of the institutions that participate in our project. It's a very honor to do science with these guys. And if someone is interested in participate with us in this kind of analysis from the water in Antarctica, is just write an email and we can work together. Thank you very much.
Thank you very much. There's one question. Question that have you tried to measure the captured methane in the ice? I mean, just take piece of the ice, melt, and to measure methane, just to prove that it's really come from the.
Yes, in our second Antarctic mission, we put the instruments in the glaciers, but these results is from 2023, and the next yes, well, yes, we did. Just wait for the publications, but
Thank you. Any other
you're
question?
welcome. Yes, it's very important. Measuring the ice. Yep.
Yes. I don't know. There's any question?
No more questions? Okay.
No more questions. Right. Thank you very much for
To you.
presentation.
Thank you. Oh, muchas gracias.